So the second part of the experiment today involves Archimedes' principle, and of course there's a famous story about Archimedes. Basically, the king of Syracuse, who I think was Philip at the time, but I'm a physicist, I'm not a historian because I have a functioning brain. So I shouldn't probably leave that in, but I've already done 4 takes of that, so I'm not changing it. So the king of Syracuse came to this jeweler, gave him some gold, and said, make a crown out of it. And the jeweler returned the crown, and the king, as kings are wont to do, was a bit paranoid and wondered, okay, well, is all the gold I gave him actually present? And of course Archimedes, being the foremost scientific figure of his age, as I am of mine, was asked, can you work this out for us? So it's easy enough to get the density of material when you've got a regular shape, when you've got a cylinder, a cuboid, whatever. It's a simple set of measurements and calculations. But with an irregular shape, it's much more challenging. So Archimedes thought about the problem for a while. He had a tough day, a long day slaving away in the Greek science mines, and he came home and he had a bath. So he kind of got into his bath, he kind of sat down, miming sitting down in case none of you have ever done that, and he noticed that the water in the tub kind of overflowed, so the water spilled over the sides, and he immediately realized what this meant. He leapt out of the bath and just ran down the street shouting, "Eureka, Eureka, Eureka." If you don't speak ancient Greek, Eureka means my buttocks are tremendously clean. But what he'd also realized was Archimedes' principle as we know it today, which is the weight of the fluid displaced is equal to the weight of the object supported by it. So we get this definition of the buoyant force. And this is what we're going to explore in the next part of the experiment.